Alright, starting off with Unit 2, we are talking about polynomials to begin with. So we want to recall what a polynomial is and how to determine if a function is a polynomial and what it means for a polynomial to be in standard form. Okay, definition of a polynomial. So this is our generic polynomial right here, and in order to make it a polynomial, we need to let n, so we're referring to this n and this n, those are the same, that n, and so on. So let n be a non-negative integer. That's going to be a key thing later on, so integer. And a sub n minus 1, and so on. So down to a sub 1, comma, and a sub 0. Those need to be real numbers. And we talked already about what it means to be a real number. Where a sub n does not equal 0. Because if a sub n equals 0, then it kind of ruins the whole thing. So if n is a non-negative integer and then the coefficients are all real numbers, where this one cannot be 0. Any of the others can be 0, that's fine. But the leading coefficient cannot be 0. So if all of this is true, then f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, yada yada. This is a polynomial function. With degree n. And that's going to be important because we're going to want to be able to identify the degree of a polynomial. Also, standard form is what we have here, where the degrees are in descending order. So what I mean by that is the degree of the polynomial is the highest exponent, which in this case is always n if it's in standard form. So that's the degree of the polynomial. But each term itself also has a degree. So this term would have a degree of n minus 1, this term down here has a degree of 1, this term has a degree of 0, because there's no x. So when a polynomial is in standard form, it's when the variables are written with the degrees in descending order. Okay, so that's our definition. Now let's look at some stuff that we can get from a polynomial that is in standard form. So the first thing is the end behavior. What we're talking about with end behavior is as the graph goes to the right and as the graph goes to the left, what is it doing? Is it going up or is it going down? Those are your two choices with a polynomial. The way that we can figure this out is with what we call the leading coefficient. So we can make this nifty little chart where on the left-hand side I can have the degree, and what I care about with the degree is the degree even or is it odd? And then on the top we can have the leading coefficient, and you'll see me abbreviate this a lot as LC, just so I don't have to write it every time. And with the leading coefficient, we care about, is it positive or is it negative? So if we compare these, then we can determine is what the end behavior is. So if the degree is even and the leading coefficient is positive, the end behavior will be up left, up right. If the degree is even and the leading coefficient is negative, the end behavior will be down left, down right. If the degree is odd and the end behavior or I'm sorry, and the leading coefficient is positive, the end behavior will be down left, up right. And if the degree is odd and the leading coefficient is negative, the end behavior will be up left, down right. So now, I just told you that information. What I want you to do is, so this chart's great, but it really shouldn't be something you have to memorize. I want you to think about, how does this end behavior relate to graphs or examples that you already know? Most specifically, or the easiest way to do that, is think about the common functions that we went through and think about some basic transformations. And so think about end behavior. So I want you to write down how the common functions and basic transformations can help you remember this. So pause the video and do that. Unpause when you're ready to move on. Alright, the last two pieces of information we can get from just looking at the equation of a polynomial is the possible number of extrema and the possible number of real zeros. So notice they are already underlined, but possible is an important part of this. And for the zeros, we're only talking about the real zeros also, because we know that not all zeros have to be real. So, possible number of extrema. Extrema are relative maximums and minimums, or turning points. So these are, we talked about relative maximums and minimums last unit, if you recall. So the way to figure this out is you are going to do the degree minus 1. So remember, the degree is n in our generic form of a polynomial. So the possible number of extrema or terms, or relative maximums and minimums, is the degree minus 1. The possible number of real zeros is the degree. Remember, it's possible. So there could be as many as the degree, or there could be less. Alright, let's do an example. So I want you to tell me everything you can about the function. So I want you to tell me the degree, the number of terms. So terms is a phrase you should know. The end behavior, the possible number of extrema, the possible number of real zeros. Then I want you to actually find the real zeros, and yes, we do know how to do that. And I want you to find the y-intercept. You should also know how to do that. So I want you to pause the video and go through doing all of those. Unpause when you're ready to check your answers. Okay, so we want to find the degree. The degree is the largest exponent. This is in standard form of a polynomial, so the degree is 5. Now the problem didn't ask us for this, but the leading coefficient is 1 because the number in front of this term is a 1, although it's not written there. There are 3 terms. If you are confused on that, you need to either look that up on your own or discuss that tomorrow in class. The end behavior. So I look at the leading coefficient, it's positive, the degree is odd, so the end behavior is down left, up right. Possible number of extrema is 1 less than the degree, so the degree is 5, that's 4. Possible number of real zeros is 5 because it's the same as the degree. The actual real zeros, there are only 3 of them. They are 0, root 2, and negative root 2. If you do not remember how to find zeros, then you need to look back at what we did last unit. That is your responsibility. The keep in mind, there are other zeros in this case also, they just weren't real. The y-intercept is the point 0, 0. Okay, so polynomials, standard form, degree, leading coefficient, end behavior, that's our little chart. Possible number of extrema, degree minus 1, possible number of real zeros is the degree.